In general, the netlist file contains all the design information, and the MDL control file contains all the measurements to be evaluated. With these two files, you can run Spectre MDL simulations either using the plus MDL switch, along with Spectre command, or using the Spectre MDL command itself, as shown in this example. Here is a list of switch options which you can use with Spectre MDL command, where the vertical bar separates alternatives. More examples of executing Spectre MDL in batch mode using the Spectre MDL command is discussed here. If the design netlist file and MDL control file have the same base name, like input.scs and input.mdl, then they can be run by just specifying the MDL file name as mentioned here. But if the Spectre netlist file and MDL file have two different base names, like input.scs and myfile.mdl, then they can be run using the following command with design and batch switch options. Here, by default, when you run using the Spectre MDL command, all the measurement results are saved in file with batch name.measure. So for a netlist file input.scs and MDL control file input.mdl, the default measure file will be input.measure. However, if you are interested to save it in a different measure file, then use the measure switch command and provide the new file name as myoutput.measure. Next, if you are interested to save all the measure outputs into a tabular format, then provide the tab switch in the Spectre MDL option as stated in this example.
Here in this terminal, let's first examine the files present in this directory using the ls command. You have the am.scs file, which is the design netlist file, am.mdl, the MDL control file, and the models directory containing all the model files. So here is a netlist file am.scs, which is already open. Notice that it's in Spectre format with the model files included with typical corner section. Then you have the amplifier subcircuit design and the test bench information. Now scroll down and note that at the end of the file you have the Spectre analysis and output option statements. Here you have a DC and AC analysis defined with the analysis name DC1 and AC1. Also at the end of the file you have the statements that changes the controls using the alter group statement. Now move to the MDL file am.mdl. Here note that you have two measurement alias blocks for the two analysis with its measurements. The measurement alias is a reusable procedure that includes a single analysis statement and a collection of one or more MDL expressions to be evaluated with the export variables. Then these two analyses, AC1 and DC1, are the AC and DC analysis statements defined in the netlist file. Then at the end of the control file, you have the run statements that refers to these measurement alias AC run and DC run. Now let's run a Spectre analysis with the MDL control file in the command line terminal. Here, before running the simulation, note that you have both the netlist file and the MDL control file with the same base name amp. So actually you can run Spectre MDL by just specifying the MDL control file. However, let's run it with the design netlist file. So type Spectre MDL -batch and then the MDL control file am.mdl. Then specify -design and then the netlist name am.scs. Then press enter to start your simulation. After the simulation is completed, examine the files generated from the simulation using the ll command. You have the am.raw, which is the simulation raw result directory. The results available in this directory can be plotted using the Virtuoso Visualization and Analysis, the Weaver tool. Then you have the am.measure file, which is the output file containing all the measured values. Then .mt0 and .mt1 are also files associated with the measurements. Then am.log is the simulation log file. Now let's examine the simulator measurements from the am.measure file with the more command. So type more am.measure. Here you can notice that it has the measurement results like DC gain, 0 dB cross of AC analysis, and the input offset voltage VIO of DC analysis. Thus, you can use the MDL control file and measure your simulation results. Thanks for your time.